Hello class, I'm going to introduce you to Theory A, Points of Intersection of Graphs of Chapter 7.6 Applications. So prior to this paragraph, we've taken a look at the product sum method and other ways of factorizing. We've taken a look at how to solve quadratic equations in different ways, the solution methods. Now we're going to take a look at how we can apply all that knowledge in, you could say, applications. More practical exercises. So for example, an exercise that you can get is something with the intersection points of graphs. So right here, for example, calculate the coordinates of the points of intersection of the graphs y is x squared minus 2x and y is minus x plus 2. And they don't have to give you a sketch with this, but in all the exercises that you get, you also get a sketch with this, so you know what they're talking about. So y is x squared minus 2x is a parabola, right? You see it right here. And the other one, y is minus x plus 2, is this straight line. And you see that they labeled the intersection points A and B. How can I now calculate the coordinates of A and B? Well, remember, in the intersection points, the parabola and the straight line are equal to each other. So you could say if they are equal to each other there, well then the formulas or the functions should be equal to each other as well. Here we have x squared minus 2x, here we have minus x plus 2. If they should be equal to each other, then I start by simply making them equal to each other. And this is equation, right? Quadratic equation. So now we have to use our knowledge from our prior paragraphs to solve this. So I think we first want to make the right hand side 0. The book does that by first adding x to both sides and afterwards doing minus 2 on both sides. And then you've got this, and I go one step further in one go. And then they say, well, you have x squared minus x minus 2. I have to use the product sum method to solve this. How do I do that? Well, I have to find two numbers which added are minus 1 and multiplied are minus 2. 1 times minus 2 is minus 2. 1 plus minus 2 is minus 1. Now solve for x, so now you can say this thing is 0 or that thing is 0, right? And then we find x is either going to be 1 or x is going to be 2. But now we're not done yet, because we did find the x coordinates of a and b. I think the x is minus 1 belongs to a, because it is left to the y-axis, so its x-coordinate must be negative, minus 1. And the b-coordinate should be, or the x-coordinate of b should be 2, because it's right of the y-axis. And here, the figure here already says how you can calculate the y-coordinates. Well, you fill in your x into your linear formula or into your quadratic formula. And it doesn't matter which one you choose the one you're more familiar with, which one you find easier. And in my personal experience, that is almost always the linear formula. So you see that the book says fill this in minus x plus 2. So then they say, well, my x is, yes, let's show it all. They say my x is minus 1, so fill in minus 1 inside of my formula right here. So I change the x into minus 1, gives me y is minus 1 plus 2 is 1 plus 2 is 3. So that's my y coordinate now, right? So the coordinates of a are minus 1, 3. And if I fill in x is 2 inside of this formula, I find 0. So b is 2, 0. And I could already kind of saw that coming in this graph, right? In this sketch. Because you see that b is on the x-axis, and when a point is on the x-axis, its y-coordinate is 0. It hasn't moved up or down. But for A, you couldn't see what it was because they don't label the y-axis here. So this could be on height 3, it could be on height 10, I don't know, because I don't know the scale of the axis. Okay, so long story short, if you have anything like this, say that the parabola and the straight line are equal to each other, then you get a quadratic equation, solve it using the different methods that we discussed prior to this. You find x is something or x is something, you find two x coordinates, figure out which one belongs to which one using the sketch, and then fill it in inside either this one or that one to now find the y-coordinate, and then also give that point as a coordinate like this, right? If you still find it difficult, please watch my video about exercise 69 as well. Good luck!